Alrighty, time for another lesson here in Unit 7 about statistics. Today our big idea is about normal distributions. And you might also hear this called the normal distribution curve. You are probably already familiar with this idea, and so we're going to delve deeper into it. The normal distribution curve is what your teachers and what all of society also calls the bell curve. So you've probably seen some kind of drawing like this before. That is a normal distribution curve. Now that normal distribution curve that we see is something that SAT uses and lots of other places, but SAT is one that you guys are very familiar with. Their goal is to separate scores in this kind of bell curve so that a big majority of their scores are happening right in the middle. In the case of SAT, we're talking about scores somewhere from about 850 to somewhere around about 1100, right? And so most students score within that kind of range. That's considered a nice average score. And so that word that I just used, average, is going to be a pretty main idea here in normal distribution curves that we're going to talk about today. That average, remember, is also called the mean. All right, so when we talk about the mean of a data set or an average that's going on here, we're looking at something that's going to be right there in the middle part of it. So an average is going to tell you where your middle part is of your normal distribution curve. And then there's always that little bit of wiggle room that tells you how far above and below that average is considered normal. Okay, so notice we're using the air quotes for normal. So that normal distribution curve tells us it's normal to be a little bit outside that. That's where most people are going to be. And then there are some people that are scoring much, much lower on the SAT and much, much higher on the SAT. But as you look at those scores that go to the very high end, like the highest possible 1600, we're only going to have a very few number of students that are scoring at that top range. So the SAT is specifically designed to separate students in this matter, to kind of put them in these kind of groupings so we can see if you're within that average range, if you're above average or below average, or if you're at the very exceptional high end or low end. So we're going to be seeing this thing in the middle here, and you're also going to be seeing this in shorthand. So the average or the mean that's right in the middle. We often use this Greek letter that looks like this, and that letter is called mu. Okay, so if you see this kind of symbol show up somewhere, you know that they're talking about the mean or the average of the data set. So we're talking about the mu going on there. And the last word I want to introduce you to here in the intro before we get going into the lesson is what makes this range that goes on either side of the mean. It helps us set what the normal distribution curve is. This separation that we have here from the very center mean to the first kind of range that we have here, each of these ones, this thing is called a standard deviation. Now, a standard deviation, if we break those words down, really makes sense about what it's doing. Standard means kind of normalized, or what is an expected deviation, or an expected difference from the mean that we have. So we have one standard deviation above the mean and one standard deviation below the mean. And that gives us this kind of middle ground here that we expect most people are going to fall within. And then if we add another standard deviation, this means things are a little bit more, not quite normal, but we start seeing this taper off going on when we're 2 standard deviations away from the mean. So we're always talking about in the middle here, and there's 1 standard deviation above and below. And then if we add another standard deviation, that means we're 2 standard deviations away. Okay, A little bit later, we're going to see that each of these sections has an expected percentage that we would expect to fall within that category, but we'll get to that point in a little bit. This standard deviation and the mean are the two things that we need in order to build a normal distribution curve. All right, so today we're really talking about normal distributions. We're going to be looking at a lot of different kinds of data, and I'm going to turn now to some of our information from our workbook. So, I'm on lesson 5 from our workbook. And we're going to zip through this intro just to kind of get another idea about what a normal distribution is. So this one is looking at histograms down below and how they represent a group of 500 healthy people who had their temperature taken. 3 histograms here on the left represent examples of data that approximate a normal distribution, and our 3 non-examples on the right are showing some items that are not a normal distribution curve. And so we want to look at some of the elements that make it be a distribution curve or not a distribution curve. All right. So I think if we start by what we saw in the intro, right, some of that information that we saw, what we drew before, we can see very quickly why our thing on the left is a good example of a distribution curve, but the one on the right isn't. If we take this histogram of information, we can draw a curve right above that data, and it fits that same kind of bell shape. So one of our first things that we need is the bell shape of our graph. Here, on our non-example, it's the exact reverse of it. It's like a U shape. And so we're not going to see something like this. We're looking for something that's got this bell shape. And part of that bell shape is that it has the high point right in the middle. An example on our other non-example, on the second one here, our high point looks like it's kind of skewed off to one side, right? So this one has this distribution curve that looks like this. And the fact that it drops off drastically on one side means that it's not a normal distribution curve. We're looking for this really nice, really even, symmetrical kind of shape. So not only are we looking for bell-shaped data, we're looking for a high point in the middle, right? A peak of our data in the middle, and it's very symmetrical. All right, this one is a little off balance, this one's upside down. This guy is also has that same really nice bell-shaped curve going on to it. And our last example and last thing that we need to make sure that we know about, I'm going to zoom in on some of this data here so you can see these numbers a little bit better. One of the things that we also know about distribution curves is that our scale on our y-axis matters. Right? The last part of a distribution curve that we're looking at this, these numbers have to be less than 1. And the reason for that is that really what we're looking at is that all of these numbers that we have along the side represent percentages. So what percent of the survey or the experiment or whatever it is, however we collected our data, what percent of that is within this certain range? Now it can't possibly be 110%. If one bar represents 110%, like we're looking at in this graph, that just simply doesn't make any sense. Mathematically what we're looking at is that all of the area underneath the curve, all of this data, is going to total 100%. Right? So it's going to total 1 because 1.00 is the same as 100%, right? So we can now see that each of these bars represents, these top ones are about 22% of the data. So we're looking at something that must be less than 1 on our Y scale going on there. So these are our main ideas for things that we need in order for it to fit the definition of a normal distribution. Bell-shaped, high peak in the middle, symmetrical, and the Y scale scale must be less than 1.